So, like I said, we're going to recap pretty much everything we've talked about because we went through all the simple rules first, and then we kind of went crazy with the product bases and throwing everything in there, so much so that we kind of forgot how the simpler ones actually work. So we're going to look at each of these rules. We're going to look at with a regular base how we do it, and then how is that different from how we do it with a product base, okay? I understand this is not the most exciting thing in the world, but it's what we're taking a test on Thursday, so we're going to push through, all right? So over here, regular base, product rule. What is my base here? 4. My base is 4. So if I'm multiplying like bases, I keep the base the same, 4, and I do what with my exponents if I'm using the product rule? What am I going to do with those two exponents? I'm going to add them. What is my new power of 4 going to be then?
7.
Everybody with that so far?
Yeah.
Okay. Now, how is that different from when we have a product base? Well, what's my base over here now?
X.
What's my base over here? X. My base is not 2. My base is not 4. The 2 and the 4 are a separate thing almost. So I'm going to take my 2 and my 4 and I'm going to multiply those out in front. Then I'm going to take my base of x with my power of 2 and my power of 5. And what am I going to do with those two exponents again? I'm going to add them. So my coefficients in the front, 2 times 4, what does that give me?
8.
That gives me 8. What's my base?
X.
X. And what's my power of x? 7. There was a lot of people on the quiz who looked at a question like this and wrote their answer like this. What's wrong with that answer? There's an 8, there's a 7, what's wrong with it? There's no x. Why does there need to be an x? Because x is the base, right? Yes, if you multiply the 2 times the 4, that's great. You can't just throw the 7 up on top. 8 is not the base, right? That's the main difference between a product base and a regular base, is that we think that, 4 and x are the same thing. 2 and x are the same thing. They're not. They're separate. So notice my powers 2 and 5 were the same, right? 2 and 5, now my power is 7. 2 and 5, my power is still 7. But what changed was the base went from 4 to x, and we had those two coefficients in front that we actually had to multiply, not add together, right? Quick show of thumbs, how much sense is that first one making? Product rule. Okay. Now, the quotient rule, we could do this one of two ways, right? Like we learned originally, we could subtract my exponents down, Or I could expand this out. I'm going to expand it out. That's the way that I've seen us feel more comfortable with doing it. So that's how I'm going to do it. If I have 5 to the 8th power, how many times am I going to multiply 5 by itself? 8 times. That's exactly what the exponent tells me. What about if I have 5 to the 3rd? How many times am I going to write out 5 there? 3 times. I'll put it back, hold on. How many pairs of 5s can I circle up and cancel from the top and the bottom? 3 pairs of 5s. 1, 2, 3. How many 5s do I have left on the top? 1, 2, 3, 4, 5 5s on the top. What do I have left on the bottom? I have nothing, which means I actually have a 1. Now, do I need to write 5 to the 5th over 1? How can I write that so it's a little bit better? Just 5 to the 5th. Now, if I took my 5 to the 8th over my 5 to the 3rd, and I subtracted my exponents downward, 8 minus 3, what would my new power of 5 be? What's 8 minus 3? 5. So my base stays the same, and my powers get subtracted downward, leaving me with 5. The reason why I want to move away from thinking about that is because when I now look at a product base, it's not that easy to just subtract downward, right? Because we get mixed up on where my terms are supposed to be. So if I take this product base, right? 5x to the 8th over 10x to the 3rd. Notice my powers are the same. I've got an 8 on top and a 3 on bottom. I've got an 8 on top and a 3 on bottom. But my bases are different, yes? Yeah. On the top, how can I expand out 5? Just 5. Or 5 times 1. And then again, I have 8, but this time I don't have 8 5s. I have 8 what? 8 x's. Buzzy. Everybody see how we expanded out the top like that? Yeah. How can I expand out 10?
5 and 2.
5 times 2. How many x's do I have on the bottom?
3.
I've just got 3. Any numbers that I can circle up and cancel?
5.
Pair of 5s. And how many pairs of x's?
3.
3. 1, 2, 3. Okay. How many x's do I have on the top? I've got 5. So I've got 1 x to the 5th over, what's the only thing on the bottom? 2. Do I need that 1 in front of the x? No, it doesn't hurt if you put it, but I'm not going to put it. X to the 5th over 2. So check it out. With the regular base, I went through all that work, and my power left over was 5. Everybody see that? Over here, my base is now an x, but my leftover power is still a 5 because I started with an 8 on top and a 3 on bottom, 8 on top, 3 on bottom, right? But because I had a bigger coefficient down below, I have that extra 2 left over there. That's not something that we had in the first one. We just had that 1 on the bottom. But here we've got that extra 2. So what happens is if I have a product base like this and I try and do the subtraction thing with the quotient rule, you subtract, 8 minus 3 is 5. Okay, so x to the 5th has got to be on the bottom. But where did x to the 5th actually end up? On the top, right? Where there's more powers, there's going to be the term. So if I have a higher power of x on the top, I'm going to have that x on the top. Notice my coefficients. I have a bigger coefficient on the bottom. Where's that number going to be? On the bottom, right? So that's our quotient rule. Like I said, I feel like from what I've seen, we're more comfortable with this than the other ones. But quick show of thumbs, how much sense is that one making? Okay, cool. Third rule, power rule. Power rule is where we distribute and multiply. Distribute and multiply. So here I've got 3 to the 4th raised to the 2nd. What's my base for this problem? 3. Right? Whatever my base is, I'm not changing it. I'm not multiplying my base by anything. I'm not adding anything to my base. My base is my base. Right? So I'm going to keep 3 the same. But I'm going to take this exponent. And whenever we distribute, we like to draw a little arrow to exactly what we're distributing it to, which in this case is the 4. Well, when I think of distribute, what should my brain think of again?
Multiplication.
Multiplication. So I'm going to take that 4 and that 2, and I'm going to do what with them? I'm going to multiply them. Should I multiply this base 3 times 2? No, the base is the base. Keep the base the same. What's my new power of that base going to be, though? 3 to the 8th power. So if it helps you to understand how to do this better, identify what the base is. That way you can check and see, in my answer, my base should still be a 3. Again, base being the big number where an exponent's attached to. So if I say, hey, in this problem my base is 3, I know that my answer should be 3 to some power. What's my base over here, though? X is my base, not the 3, the x. So x should not be changed. X should have some exponent up on the top in my answer. That's what I know for sure, right? What do we call that 3 in the front?
Coefficient.
It's a coefficient. That's going to change. Is 3 part of my base? No. It's its own separate thing. So because it's not part of the base, it's going to change when we do this. In the same way that in the quotient rule, my 5 over 10 changed into a 1 over 2. But my x stayed as an x. In the product rule, my 2 and my 4 changed into an 8, but my base was still x, right? So I think that's the part that we're missing. I saw a lot of people kind of mixing all that up on the quiz. What's my coefficient here? 3. I'm going to distribute the 2 to that 3, and I'm going to separate it. Where else am I going to distribute that to? To the exponent on my base of x. And when I distribute, what does my brain tell me to do again? Multiply. Notice how I'm taking this step by step. I'm not trying to do everything all at once. I'm taking care of my big number, my coefficient. Then I'm taking care of my exponent base. Just like I said, when I have a coefficient, that number is going to change. What does 3 squared turn into? 9. Bless you. What's my base again? X. So that's still going to be my base. What's my new power of x, though? 8. 4 times 2, that gives me 8. This is a great example of how the same rule looks so different depending on what your base is, right? All I did was scoot my 3 over and put an x in there. That's literally all I did. Look at how different these answers are. The only thing in common is that 8 on the top, my exponent. Here I had a base 3, my answer had a base 3. Here I had a base of x, my answer had a base of x, just with a new number out in front. It's the same thing with all these product bases. All right? How are we feeling about that one, the power rule? A little bit better, maybe? Kind of? What questions can I answer if we have questions? Think about it for a second. I know you're not going to ask it, but think about it anyway. Yeah.
Why don't you multiply the 3 times 2 instead of put it?
Right here?
Yeah.
Good question. If I were to expand this out, right? Let me show you. It's actually a really good question. You would think, oh, I just multiply the exponent times the 3, right? Well, I can only multiply it when it's an exponent with another exponent. If it's an exponent with a coefficient, with a little number with a big number, we've got to actually do the exponent. Because 3x to the 4th squared is 3x to the 4th times 3x to the 4th. Does that make sense? If I were to expand this out, it's all of this many times. 1, 2 times, right? So now we don't have a 3 times 2. We have a 3 times 3. See what I mean? Which that would give me 9. But now I have 4x's here, 4x's there. That becomes 8 because I add those together, right? And that's exactly what we got, 9x to the 8. So this whole time we've been splitting. The coefficient should be completely split from the variable. We should always think of them as 2 separate things. What I do to one, I'm not necessarily going to do to the other. This same exponent 2 is an exponent on my coefficient, but I just multiply it on my base with my exponent. So we're not even doing the same thing with the same exponent. It's completely separate. The only time we should bring them back together is when we're putting that answer right there. Taking the first part, the second part, just making them kiss, okay? Does that kind of make sense, Lucio? Really good question. I appreciate you asking that. Finally, negative exponents. This is a process that we talked through, I want to say 45,000 times maybe. If I have, well, first of all, what's my base here? 3. All right? Let's see what happens to that base of 3. Is that 3 in a fraction? No. What do I have to do to turn 3 into a fraction? Put it over what?
1.
What?
1.
Oh, 1. Okay. All right, it's a fraction. What do I do now? We got to flip it. So what's going to be on the top now? A 1. What's going to be on the bottom? 3 to the positive 4th. Put over 1, flip, make exponent positive. We could even simplify this, right? What's 3 to the 4th power? 81. 3 times 3. 3 times 3. 9. 9. 9 times 9. 81. I'm going to leave it as 1 over 3 to the 4th because it's going to mirror what we're doing in the second one. And this second one, I don't think we talked about. Maybe we did. I don't think we did. What's my base in the second problem?
X.
Or X.
X. Is 3 my base in the second one?
No.
No. My base is X. We're going to do the same thing. We're going to put it over 1, we're going to flip it around, and we're going to make the exponent positive. Okay? What are we going to put over 1, though?
X.
We're going to put X over 1. Am I going to put 3 over 1?
No.
No. 3 is not the base. So I'm going to pretend it's not there, right? If I put X to the negative 4th over 1, right, we're pretending that 3 is not there. And then I flip this around, right, so that my 1 goes to the top, my X to the 4th now goes to the bottom. Well, what do I still have that didn't get flipped around? The 3. Where should the 3 go? On the top or on the bottom?
Top.
On the top. What is 3 times 1?
3.
Can I simplify 3 over X to the 4th at all? No. So check it out. My answers here that are all bubbled up in yellow, they look very similar. I still have my identified base with the positive 4 power on the bottom. But what's on the top is different, right? I did not have a coefficient with my regular base, so there's just a 1 up there. But I did have a coefficient on my product base. When I have a coefficient, I treat it like a completely separate part of the problem that I just add in later on the end, which is exactly what we did. Right? If I turn this into 3 times x to the negative 4th, right? Is that the same thing as 3x to the negative 4th? This right here, is that the same thing as 3x to the negative 4th? How it's presented in the problem? Yes, no, guess. Yeah, it's the same thing, right? All I did was put a multiplication sign in between. If I then take this, put it over 1, flip it around and make it positive, that didn't touch the 3 at all. It has nothing to do with the 3, right? Well, now if I'm multiplying a whole number by a fraction, I'll multiply by the top. So now my 3 is up there, and my x to the 4th is still down on the bottom. That's exactly what we got, right? So with these product bases, a lot of you are not splitting it up into 2 separate things, and that's where we get all mixed up and confused, okay? All right. What questions can I answer about those negative exponents? Are you guys feeling okay with that? Okay. I appreciate those of you